Hey, all right, guys. So I'm going over law and cosines, lesson dash 7-5. All right, so you're going to use law of sines and cosines to solve these different triangles and look for missing sides and missing angles. So let's write down what all those are first. So first, let's write down law of sines. Okay, so law of sines. And I want you to look at law of sines in two different ways to help it make it a little bit easier for you guys to solve these problems. If I'm looking for sides, which in this packet you're going to see most often where you're finding sides. What I want to do to make my life a little bit easier is I'm actually going to put the side on top. So I'll show you what I mean. Okay, so actually let's first write it like this. So if I'm looking for angles, okay, I have my angles on top. And so this is what you guys have seen the law of sines look like. Sine of A over little a equals sine of B over little b, and then sine of big C over little c, right? So that's if I'm looking for the angle.
You need to take your temperature every day when you visit campus.
Sorry about that announcement. Okay, so notice how I have the angles on top. Okay, and I'll show you how this makes it a little easier as I show you these problems. Okay, so then what if I want to find the sides? Well, if I want to find the sides, I basically literally just flip it. So now finding sides, and I put a, the little a on top, and I just put the sign of the angle on the bottom. So literally I'm just flipping this upside down. So this still works. Okay? So it just kind of saves you a couple steps when you're working through these. The last one that we're going to be using is law of cosines. And I'll show you how we can write that in multiple ways. So here I'm going to write c squared equals a squared plus b squared minus 2 times a times b times the cosine of. Now what's important is that letter right there needs to match the one that's on the other side of your equal sign. So if you're solving for c here, then you should have big C here. Okay, so now we got all the different methods that we're going to use, law of sines and law of cosines. Okay, so first, this tells us that we're going to use law of sines. So let's look at what we're looking for. We're looking for x. And notice how x is a side, right? So that means we're going to set it up with the sides on the top. So I put x on top. And now what I'm going to put on the bottom is the opposite angle to x. Okay, so this is what I call an opposite angle side pair. Basically an angle and a side that's opposite from each other. So that's what we're going to put on the bottom. We're going to put the sine of that angle. So sine of 110. And then we set that equal to another side angle pair that is known. You need to know both the angle and the side in order to do this. So that I have 24, which is opposite 12. So I wouldn't want to use a side where it's like I don't know an angle or don't know one of the sides. You need to know both. Okay, so remember I put the side on the top and then the sine of that angle, the opposite angle on the bottom. Okay, so now what I'm going to use, this method is cross multiply, which you guys are familiar with. But here's a trick that you can do with cross multiplying, which I'm going to do with all these law of sine problems, is anything that is diagonal from one another, I can actually just move this over here. So what I'm going to actually do is I'm going to just move this to the top like that. Okay? So really what this becomes is x over 1 equals 12 times the sine of 110. So I moved the sine of 110 up to here. And then sine of 24 on the bottom. Okay, so then what I'm going to do is just calculate this and then figure out what that's equal to. And let me show you why that works. Okay, so normally, if I was to cross multiply this, right, I would do x times sine of 24, so it'd be x times sine of 24 equals 12 times sine of 110. And then to solve for x, I would have to divide the sine of 24 on both sides. And notice how I end up with the same thing I just showed you here. Okay, just by moving this over to the top. Okay, so basically that's the reason I like setting these up like this. It's because I only have to make one move and then calculate. Okay, so now the only thing I need to plug in is I'm going to use a scientific calculator and plug that in. Okay, so I'm going to use the Desmo Scientific Calculator. So I'm going to hit divide so I can get the little fraction line. Okay, so I have 12, and I could literally just type this out on the keyboard. 12 times sine of 110. As long as you just type this in this fashion where you do the side and then type sine right after it, it's going to multiply the two. Okay, and I want to put the sine of 24 on the bottom. Okay, or you guys could just like go push function and then push sine, and then you'll get the same thing. Okay, so you could do it either way. You can literally just type out sine, or you can push this button, and then you'll get the same result. Okay, so now this is going to be equal to 27.7. And so what I'm going to do for all of these problems in general, when you do sines and angles, angles and sides, is we're going to round everything to the nearest tenth. Okay, so one number after the decimal. Okay, so I'm looking at the side over here. So I wrote this down, 27.7. And I'm looking at this side, and you notice how it has that one little tick mark? That means feet. If it has two tick marks, it's inches. So I'm going to write 27.7 feet, since it gives me a unit of measure. So if it gives you a unit of measure, make sure you put that on there. If it doesn't, then just write the number. So like, for instance, on this next one, it doesn't give us a unit of measure. So we're literally just going to write, we wouldn't include that. Okay, so now we're going to do the angle, which is set up very similar, but there's one extra step that's a little different. Okay, so now that we're looking for an angle, okay, which is angle Z, which basically is this angle right here, I'm going to put the angles on top, or the sine of the angles on top. So I'm looking for angle Z, so I'll put sine of angle Z on top. That'll be the first one. And then what I want is the opposite side. Okay, so the opposite side of Z, which is 6, so that goes on the bottom. And now what I need is another angle side pair. Okay, that's opposite, and that would be these two, the 40, which is across from 14. Now I'm going to notice, again, I put angles on top, so I put sine of 40 on top, and then the 14 on the bottom. And now I'm going to do cross multiply like I showed you before. So I just take this number and move it right up here. And so now it's sine of angle Z equals 6 times sine of 40 degrees divided by 14. Now, one thing that Miss Menard showed you guys is she would calculate this amount, and then she would plug that into the calculator using like the answer button. I'm actually going to set it up to where I just have to do calculation one time. Okay, so remember, the difference is when you're looking for an angle, you're going to use sine inverse. Okay, so if you're looking for a side, you just use the regular sine function. But for angles, we got to use the inverse of sine. So angle Z is now equal to sine inverse, so you put a little -1, of 6 times sine of 40 divided by 14. Okay, so what I'm going to do is I'm going to set this up on the calculator, on the scientific calculator. Okay, so to get, let's go to a new line here. To get that function, I go to function here and click on the sine inverse right there. And then I'm going to click divide. Actually, I'm going to go back to the main function here, so we have all those other buttons. Or I could have clicked this. That way I get the little fraction line. And now on the top I have 6 times sine of 40. And then on the bottom, I want to put divided by 14. Okay, so you can see here I've got 15.99. So that 9 right here is going to round that up to 10. So that means I'm going to round this also up to 16. Okay, so the angle is 16 degrees. So make sure you put the little degree symbol when we're looking for angles. Okay? All right, so now the next one. Now again, remember guys, as you're following along, remember that I'm creating my own triangle. So do your example with your values, okay? Don't copy my values. All right, so now the first question says, Beatrice noticed the two angles in this triangle here, showing it right, have the same measure. So notice how yours is 48, that's 48, this is 40, this is 40. They're equal, okay? So based on that, what statement can you make about the relationship between QP and QR? Well, if you guys remember from IM1 and IM2, when you have two angles that are the same, that means the opposite sides from them are also equal. So that means that this side, QR, is equal to the opposite side of this angle, QP. Okay, so those are the angles, those are the sides that they're talking about. So what statement can I make? Well, they're equal. So I'm going to write QR is equal to QP. okay? So if QP is equal to 3 millimeters, what is the length of PR? So if QP is 3 millimeters, this side, and we just said that QP is equal to QR, that means this is also 3 millimeters. What is the length of PR? So this side. So what I'm going to call this side, I'm going to call that little q, okay? Now, I have to make a decision here, okay? I had to decide, am I going to use law of sines or am I going to use law of cosines? Well, remember with law of sines, I need to have at least one angle side pair that's opposite from each other to be able to solve for the other one. And for the side that I'm solving for, I need to have basically an angle that is across from it. So if you look, we're solving for that side, but there's no angle across from that side. So I can't use law of sines. So then let's see how we can solve using some other method. Well, if I think about law of cosines, if I use law of cosines, I would have to have two sides, and right in the middle of those two sides, I have to have an angle. And here are the two sides I know, but there's no angle here either. So I need that angle. Well, think about it. If I know that these two are 40, remember triangle sum theorem, they all add up to 180. So that means I can add these two up and then take that away from 180. So basically I'm going to subtract both 40s from 180. So that means that that missing angle is 100. Okay, so now I have an opposite angle. Okay, so now I can pick which method I want to use because I have two sides, angle in the middle. And now, if you notice, I've got an angle across from the 100, and I have a known pair of a opposite angle and side. I always like to use sine first because honestly, it's easier than using setting up cosine problems. Okay, so we're looking for Q, right, or PR. So I'm going to set it up as little q. Remember, the side goes on top this time because that's what I'm looking for. Divided by the sine of the angle that's across from it, so the 100, equals the other pair that I know about, which is the 40 degrees and 3. And remember, I want the side on top, and then the sine of that opposite angle on the bottom. And now, just like I told you before, I'm going to use the kind of cross multiplying shortcut. I'm going to move this up to the top at it because it's kind of at an angle or it's diagonal from it. And now Q will be equal to 3 times sine of 100 degrees divided by sine of 40 degrees. Okay, so now set that up in the calculator here. So I'm going to click divide first, and I do 3 times the sine of 100 divided by the sine of 40 degrees. Okay, now I really recommend you guys using the Desmos calculator for this. If you're using like a personal calculator, like someone like this, you got to be careful and making sure that when you are looking for degrees, that you see the little thing that says DEG right here. Make sure it says that. If it says RAD, that means it's set up for radians, which we don't want it to be in radians. We're not even going to talk about radians until next quarter. Okay, it's just another way to measure angles. So the way that you have to figure out how to change that on this particular calculator, there's actually a button called DRG, and most of them say DRG. Just click that and just basically select the DEG until you're there. And then another measure is called gradients. That's what the GRD stands for. So just make sure it says DEG on there. Okay, and again, that's just if you're using this kind of calculator. If you're using like a phone calculator or Desmos, which you're always good, then you're always good. And if you notice on Desmos, it even has a button for that. So here's DEG, and if I click it, it turns it into radians. Okay, so make sure it always says DEG. Okay, this is especially a good thing for if you're doing the SAT. If you're doing SAT, you want to make sure it's always in DEG. Okay, so the side was 4 we'll round that to 4.6, and it's in millimeters, so we'll make sure we say millimeters. 4.6. Okay, so I wrote that down right there. Okay, so now the next one it says use law of cosines. So let's go ahead and write that formula down. Remember I had it here at the top. Okay, and actually before we write it down, let's actually set up our triangle first. Every time the triangle is not labeled, I like to label it. And if it's not labeled anything, I just put ABC. Okay, so we're looking for this side, which they're calling X, but I'm going to go ahead and call it B, just because it's across from the big B. And then this one is going to be little a, because it's across from big A, and then this one's C. All right, so that means we're solving for B. We're looking for that. So when I set up the law of cosines, that's my first value I put. I put B squared instead of C squared. And now over here, I'm going to put A and B on this side. So that means I would do A squared plus B squared minus 2 times A times B times the cosine. Remember, this always needs to be the angle that's across from the little b. So I put big B. Okay, so this basically need to match. So B squared equals A squared, which is 8. Okay, and then plus C squared, which is, oh, sorry, I noticed I just did that. Sorry guys, that should be a B right there. So a C. Okay, because B's on this side and A and C are over here. So C squared, which is 5. And then 2 times the A times C times the C, which is 5. And then times the angle B, which is 110. Or sorry, times the cosine of the angle, 110. Okay, so now to solve for this, I'm going to do this all in one step. Since I'm going to have to square root B squared, I'm literally just going to square root this whole thing. Okay? I'm going to square root both sides to solve in one step. And I'm going to use the Desmos calculator to set it all up. I'll show you how to do that. Okay, so I'm going to make a new line. Or you can just clear it out. It doesn't matter. The first thing I'm going to hit is square root because I want everything I type to be under the square root. Okay, just like I had it written down. So 8 squared plus 5 squared minus 2 times, again, I'm just copying down what I wrote, times 8. I'm literally just typing it the exact same way it's on my paper. And then make sure when you do the cosine, click out of this, I put cosine of 110. You want to be careful that when you do this last part, you don't go outside the radical and it starts to look like that. Because if you don't see that line over the top of it, it's not inside the radical. So make sure that you do that inside, underneath. Okay, oops, not CPS. All right, so now I got everything underneath. I'm taking the square root of all of that, add it up. Okay, so then that means my side is equal to, round that to 10.8. And it doesn't look like they're using any units, so we'll just put 10.8 units. And that's the side there, okay? Okay, so let's go to the next one. Okay, so now on this one for ABC, focus this up. For ABC, the triangle ABC, determine angle C, or the measure, this means measure of angle C, given BC equals 25, AC equals 20, AB equals 18. So basically, you need to draw out your triangle, okay? They give you the sides, and what we'll do is we'll label it because it's ABC, so A, B, and C. And I'll call this little b, little a, little c. Okay, so BC is 25, so that'd be this side. AC is 20, and then AB, which is basically side C, is 18. Okay, so it wants me to find angle C. All right, so that means this angle right here. Okay, so if I'm going to use law of sines, which is always the one I like to kind of jump towards, that means I have a side opposite the angle, which is good, but I also need another angle and side pair. Well, for this side, there's no angle here. And for this side, there's no angle. There's no angles at all. We don't know any angles. Okay, all we know is sides. So our best option, law of cosines. All right, so we're basically going to be looking for the angle C first. Okay, and that's really all we are going to be looking for. Okay, so the way we're going to set that up, so we're going to use law of cosines, and we're going to set it up with C squared on this side, because if we're looking for angle C, then we want the same side on this side of the equation. Okay, so c squared plus ab squared plus a squared plus b squared minus 2 times a times b times the cosine of the angle we're looking for. Okay, so now c squared, which is 18, okay, and then plus a squared, which is 25. That's why it's always good to label your triangles. That way you can kind of see where everything goes. Then 2 times 25 times 20 times the cosine of the angle you don't know. All right, so now we actually have to, when we're looking for the angle using law of cosines, we got to simplify. So this is probably a little bit the longest problem as far as like having to work out different steps. So we're going to simplify everything. Okay, so I got 18 squared. Calculator time. Okay, so 18 squared. Okay, that's 324. Okay, so what I'm going to do is figure out what 25 squared plus 20 squared is. So 25 squared plus 20 squared, that's 1025. So that part of it's 1025 minus, don't forget the little minus there. And I'm going to multiply the 2 times the 25 times the 20. So 2 times 25 times 20 is 1000. And then times the cosine of c. Now, some of you guys, like Miss Menard pointed out in her video, might think, oh, let's do 1000 minus, 1025 minus 1000. But you can't do that because think about it. Let's just say that there wasn't cosine here. It was actually x. So it wasn't 1000 times cosine. It was 1000 times x, right? So if it was 1025 minus 1000x, those are not like terms. So I couldn't like add those or subtract them, right? I would have to put this on the other side. So I'm going to treat that the same. So the first move I'm going to make is subtract this number, 1025, from both sides. Okay, let's see what that is. So 324 minus 1025, negative 701. Okay, is equal to negative 1000 cosine. And now again, what we're trying to do is get that c by itself. So to get the c by itself in this case is we're going to divide 1000 on both sides. So I'm going to kind of bring this up here so I can give myself more room. And be careful, make sure that you keep those negatives there. And most of the time, those are always both going to be negative so that when you divide them, they become positive. You should get a positive value here after you do this step. So if you don't get a positive, make sure you kind of go back and check and see what your mistake was. Okay, so next one, let's do negative 701 divided by negative 1000, 0.701. So now the cosine of angle C is equal to 0.701. And now remember, just like the problems before, when you are looking for the angle, you use the inverse. So now the angle C will be equal to the cosine or inverse cosine of this value. Okay, so let's use the cosine inverse function. So it's over here. I put the 0.701, and it's 45. We'll round that to 0.5, 45.5. So angle C, or the measure of angle C, is equal to 45.5 degrees. Okay. All right, so here we go. Let's get that out of the way. All right, so now what is angle Z? Now think angle Z. If I'm looking for an angle, that means I'm probably going to have to do an inverse function. Okay, so just keep that in mind as you work through this. Got to decide: is it law of cosines or law of sines? Because it doesn't tell us.
Attention.
So, oh, I love that.
You need to take your temperature every day.
I love it when they tell us about wearing a mask. All right. Anyways, okay. So, let's see what we got. We got to look for angle Z, right? That's this angle right there. All right, and remember, use your triangle, not mine. Okay, so this is angle. So if it's this angle right here, I want to try to use law of sines first, right? So that means I've got a side across from it, so that's good. Do I have another pair? Why, yes, I do. For 48 degrees and 10. So I can use law of sines. Let me write that down. Law of sines. And remember, we're looking for the angle, so we'll put the sine of the angle on the top. So sine of z, or angle z. We're doing angle z again, just like before. And then the opposite side on the bottom, so the side across from it, equal to the other pair. Remember, we're doing the angles on top, right? So we want sine of 48 on the top. And then on the bottom, we're going to put the 10. So I'm going to use my little shortcut here. I'm just going to move that 6 up to the top here. And now sine of angle z is equal to 6 times the sine of 48 degrees over 10. And then the last part is I want to do the inverse function because I'm looking for the angle. So the angle z is equal to the sine inverse of 6 times sine of 48 degrees divided by 10. All right, so now I'm going to set that up using the, scientific calculator here. Let's clear all this out. All right, so remember, type sine inverse first. Go back to this part. Divide so I can get the line. 6 times sine of 48 and divided by 10. Okay, so my angle, I'm going to round that to the nearest 10. This will be 26.5 degrees. So angle z equals 26.5 degrees. All right. Okay, next page. Okay, so the first part, top here, says, which of the following triangles can be used using law of cosines? Now remember, law of cosines, what I need is an angle with two sides right next to that angle. Basically, two sides with an angle right between them. Okay, so let's start with the first one. Here's my angle that it gives us. Do the sides, are they adjacent? Are they adjacent to this angle? Are they right, or is the angle right between them? Well, here's the angle. Sides are right on the side of it, so yes, they are right adjacent. Okay, so this one we can. Let's go to this one. Here's our angle. This side's right next to it, but this side is not known. This one is. So this one, no, we cannot. Here's my angle here. I know this side, so that means I need to know this side right next to it, and I don't. The side's over here. So we can't use law of cosines for that one. So what we're going to do is we're basically just going to solve the one we can use law of cosines with. Okay? All right, so first thing is label all the parts. So this is big A. I'll label this little a. This is little c, little b. Okay? Just makes it easier when you set your equation up, right? So remember, we're solving the triangle. When it says just solve the triangle, that means you look for everything that's missing. Okay? So we have angle A. So actually, let's write out everything we do now. Let's write all the angles first. And then we'll write all the sides. Just so we know what we have and what we don't have. Okay, do we have angle A? Yep, 38 degrees. Do we have angle B? Nope. Angle C? Nope. Side A? Nope. Side B? Yep. Side C? Yep. All right, so this is what we're looking for. Angle B, angle C, and side A. Okay, so I'm going to look for sides first because sides are typically a little easier to find. So I'm just going to start with that. So we're going to start with side A. That's the only side we need to find. That would be this side here. Now, side A is across from 38, so that is an angle side pair. However, the only information we know are these two sides. So that in order to use law of sines, one of these sides needs to have an angle across from it. Well, 13 doesn't have one, and 11 doesn't have one. So that means our option is to use law of cosines. Okay, so if we're looking for A, I'm going to put that first.
Don't forget, to prevent the spread of illness.
Okay, so we're going to set up with A squared first. Okay, because that's the side we're looking for, which means that, let me actually set up how we're going to solve this. So it'll be A squared first because that's the side we're looking for. So that means we're going to have B and C on the other side of the equation. So we'll have B squared plus C squared minus 2 times those same sides. So times B times C and then times the cosine. Remember, the cosine of the angle should be the same angle across from the side you're looking for, which is A. All right, and we do know that it's 38. So let's just plug it all in. So b squared, 11 squared, c squared is 13 squared minus 2 times those same sides, 2 times 11 and 13, and then times cosine of the angle that's across from A, which is 38. Now, the nice thing about setting up law of cosines when you're looking for a side is that I can just simply square root both sides and then just plug all of that into Desmos. All right, so here, I'm going to push the square root first. You guys have seen this a couple times already. So plus 13 squared minus 2 times the same sides. So that you separate your parentheses if you're using that. And then times the cosine of 38. There it is, 8 point. Okay, so we typed it in. Oh, let me move my head. I had to pause for a moment. Okay, so we got 8.0. Okay, because round that to your nearest tenth, which is 8.0. Okay, so A equals 8. And there's no units, so I'm just going to put 8 for A. So let's fill that in right there. Okay, so now I got to decide, do I use law of cosines or use something else to figure out the next side? Or angle, actually. We're looking for angles now. Well, usually once you use law of cosines once, usually you're able to use law of sines after that. So let's see if we can find an angle side pair. Well, the side we just found, there's a pair, okay? And we need to find B or C, so let's go look for B next. Here's the side across from B, right here. So that means I have a pair right there with the side that I'm looking for, and a known pair. In other words, I know both the angle and the side now. So now I can plug that in and use that. So remember, I'm looking for sine for B, so I'm going to put that on top. So remember, again, when you're looking for the angle, put it on top, and then put the side across from it on the bottom, which is 11 for me. Remember, for you guys, it's different. And then I'm going to put the sine of the other angle of the pair that I'm going to use, which is the 38 degrees and the 8. So I put sine of 38 and then the side on the bottom, which is 8. And now, again, I'm going to get that angle by itself. I'm going to use the kind of cross-multiplying shortcut by bringing this 11 up here. So sine of B equals 11 times sine of 38 degrees over 8. So remember, when you're looking for an angle, now I need to use sine inverse. So now, put that there. So B, the angle B, is equal to the sine inverse of all of this, 11 times sine of 38 degrees, divided by 8. All right, so let's plug all that in using Desmos. All right, let's clear all this out. Okay, so first let's type the sine inverse. Then I'm going to go back to main, click divide, so that I can get that line, or fraction line, or rational line, whatever you want to call it. 11 times sine 38 divided by 8, and we get 57.8. So we'll round that to the nearest tenth, which is 57.8. So B, or angle B, and actually we probably should be using that symbol, not a degree symbol. Okay, it's just when I write it here, it's just kind of weird. I don't like to fit it in there. So 57.8 degrees. That's our B. Now, we have one more angle to find. If I have two angles, and I know that every triangle, they all add up to 180, I can use the triangle sum theorem. So first we use law of cosines. Then we use law of sines. Now we're going to use the triangle sum theory. All right, so I know that they all add up to 180, so I basically will just take away those angles from 180. So 180 minus 38 and then minus 57.8. Well, that will equal angle C. So let's calculate that out. So 180 minus 38 minus 57.8, 84.2. 84.2 degrees. There's my last side. So again, if it says solve the triangle and it doesn't specify what exactly to solve, you're solving everything. It might even just say solve the triangle. Or it might say find all the missing sides and lengths or angles. Okay. All right. Next one. You now have several tools to solve and for missing sides, lengths, and angle measures in triangles. Decide which tool to use for each of these triangles below and solve for x. Decide if your answer is reasonable. All right, so I want to remind you that one thing that you guys haven't seen in a little while, you haven't seen since IM2, is SOHCAHTOA. All right, and we're going to be using that in one of these situations. Okay, so let me write that up here for your notes. So if you guys remember SOHCAHTOA, remember the first part, that's sine. It says that sine is equal to opposite over h, which is a hypotenuse, part of the, and again, this is just for right triangles only, right triangles only. Okay, so then cosine is equal to a, which is adjacent, over hypotenuse. And then the last one is t, stands for tangent, is equal to opposite over adjacent. So I'm just writing that for your notes because we're going to need that. And if you notice, we have a right triangle for problem B. All right, so first let's go to problem A. All right, so problem A, taking a look at it, I always try to see if we can use law of sine. So it's not a right triangle, so we're using either law of sines or cosine here. So let's see. This side and that angle, okay, are opposite of each other. So there's a pair. And I forgot to include the x here. There's the x's right there. And I'm looking for that one, right? And I have an angle across from that x. So I have an angle side paired that is complete and one that has an unknown. So that works. Okay, so remember since I'm looking for a side, I put that on top. And I put the sine of the opposite angle on the other side. So sine of 18 degrees. And then I put this side, the other side on top, across from sine of the opposite angle to that one. And I use my little cross multiplying trick. So this is going to go up here. So now it's 7.5 times the sine of 18 degrees divided by the sine of 32 degrees. All right, so let's set that up. So now we have, what is that? Let's hit divide first. So 7.5 times the sine of 18 divided by the sine of 32 degrees. So 4.4. So x equals 4.4. And there's no units there, so I'll just say 4.4 units. That's it. Okay, now this one, I have a right triangle. And in right triangles, I can use SOHCAHTOA. Okay, so I am looking for this angle. So remember, when you think angle, that means I'm going to have to use inverse sine. So I'm using inverse sine again. And now to help us kind of look at this, I'm actually going to flip the triangle around so that that right angle is kind of like is kind of on the bottom side. It's just easier, honestly, for me to see like what the triangle looks like and what's opposite, what's adjacent, what's a hypotenuse when it's flipped up this way. So 4 goes here, 7's on the bottom here, and then x is right here. Okay, so what I need to look at is what sides do I have in basically in accordance to the angle that we are looking for. Okay, so here's the angle we're looking for. How does this side relate to that? Well, it's across from it or opposite of it. And then the 7, how does that relate to x? Well, it's right next to it or adjacent to it. So which SOHCAHTOA function, sine, cosine, tangent, has opposite and adjacent? That would be tangent. Okay, so a tangent, I can use opposite and adjacent sides to find the missing parts. Okay, so we're going to use tangent of x, of angle x, equals the opposite 4 over the adjacent 7. Now, again, I'm looking for the angle, so you find the angle of x. I'm going to do the tangent inverse of this ratio, or this proportion, or whatever you want to call it, this fraction, okay? So let's plug that in. So just like before, go to function, tangent inverse here, and then it's basically 4 divided by 7, and we will round that to 29.7 degrees. So angle x is equal to 29.7 degrees. Okay. Okay, so now the next one. Let's look and see what we have. Okay, so I notice right here that this one is across. There's an angle side pair because I'm thinking law of sines. That's across. But I need another angle, and I only have one angle. So law of sines isn't going to work. And it's not a right triangle, so I can't use SOHCAHTOA. So that probably means I'm going to use law of cosines. But in order to use law of cosines, kind of like this problem, remember that the angle needs to be in between the two sides. Well, if you notice here, this angle is right in between 10 and 6. So yes, we can. Okay. So to set this up, what I want to do is let's actually label the triangle. I like to label it when I'm working with like law of sines and law of cosines. I know I didn't do it here, but it's definitely helpful for law of cosines because you're kind of like trying to figure out like where do I put it in the equation? Do I put the A here, the B, the C? Which one goes there, and then which ones go over here, right? Okay, so we'll call this C. We'll call it the side we're looking for. We're going to call it actually B. Okay, so when I solve for this at the end, the answer X will actually be the B. Okay, so this is across from A, so that's little a. All right, so I'm looking for B, right? So that means that one goes first, B squared. Equals the other two sides squared. So A squared plus C squared minus 2 times A times C times the cosine of, remember, these two need to match. So if that's little b, then this will be big B. All right, so let's fill it in. So B squared equals A squared, 6 squared, plus C squared, which is 10, times, or minus 2 times A, which is 6, times the same sides, 10, times the cosine of B, angle B, which is 19 degrees. So now we square root both sides. Since we're just solving for the side, remember when you're solving for like the cosine or the for the angle, that's the one where we have to like work out all the steps and simplify. There's that one problem that we did on the last page right here. We were solving for the angle instead, and that's when you got to simplify and figure out all the different values and get the C by itself. But when we're just solving for the side, I can literally just set this up and square root it, or square root both sides. Okay, so first hit the square root, and then we've got 6 squared plus, what was that, 10 squared, oops, square button, minus 2 times 6 times 10 times the cosine of the angle B, which was 19 degrees. And remember, like I told you guys before, make sure that's under the square root. So it's 4.7. Okay, so B equals 4.7. And remember, it's a side, and there's no units, so I'll just say 4.7 units. Okay. Now I know we were looking for x, so I could substitute B for x and put just x there, because that really was what we were looking for, not B. But I just use B because that just makes it easier to set it up. Okay. All right. So now the last one. So the guidelines set forth by the National Kitchen and Bath Association recommends that the perimeter of a triangle connecting the fridge, which is this guy right here, here's the refrigerator, the stove, and the sink of a kitchen be less than 26 feet, or be 26 feet or less. So what that means is that wherever the location of the sink, the fridge, and the stove is, it forms a triangle, right? So I can form a triangle based on where those are located. Once you form that triangle, they're saying that the perimeter of that triangle should be 26 feet or less. That's what they recommend, okay? So this girl, Lashaya, ooh, I just murdered her name, Lashaya. Oh man, pray for me. Okay, so Lashaya is planning to renovate her kitchen and has chosen the design below. Does her design conform to the National Kitchen Bathroom Association guidelines? So in other words, is her perimeter going to be 26 feet or less? Okay. So in other words, we need to find the perimeter or find all the sides of that triangle for her situation and add them up. Okay. So let's kind of set this up here. So the perimeter is going to be all the sides added. So let's label the sides. We're going to call this A, we'll call that B, C angles, and we'll call this is little a, this is little c, little b. All right, so we need to add up A plus B plus C. That'll give us our perimeter. And then we'll know, and then it needs to be, this needs to be less than or equal to 26. If it's less than or equal to 26, then we're good. All right, so what do we know? Let's write down that first. Do we know A, B, or C? We know C. 6.9. And remember the little tick mark, if it's just one, that means feet. So 6.9 feet. So we need to find A and B, okay? So let's look at the information they give us. Now notice how they give you these measurements right here. They give you the distance from the sink over to this counter over here, and the distance from the stove to that same corner. And notice what that forms right there. There's a 90-degree angle, they say a right triangle, okay? So if there's a right triangle, that means we can use those sides right there in the right triangle to find this side or find side A. Okay, so I've set up some different numbers here. Those are your numbers. These are mine. And you might want to redraw your triangle down here. It might be helpful to make it a little bigger and kind of see where all the sides are. But let's start by finding A, okay? Now, the first thing I'm going to do to find A is, first of all, I can't use the values in the triangle here to find A because all I have is one angle and one side. That's it. I don't have another angle over here. It's opposite. I don't have another side to use a lot of cosines. I couldn't even use SOHCAHTOA because there's no right angle, okay? And I can't use SOHCAHTOA either to find the side. So my only option, if you guys remember how to find a missing side in the right triangle, is Pythagorean theorem. Pythagorean theorem. So a squared plus b squared equals c squared. Now, don't get this confused. I know it says a squared plus b squared equals c squared, but that's the triangle we're using right here. So let's make sure we know. Let's actually just kind of draw it out here just so we know what we're talking about. All right, so the 3 goes on this side. The 6 is here, right? And then we're just looking for that side right there, okay? So we'll call that side C for now. All right, and that's the side that's right here, actually. All right, so this is kind of like our sides, and that's our hypotenuse. So that's the left side. So we're going to set this up as 3 squared plus 6 squared equals the hypotenuse squared, which actually really is A. Okay, it's actually, it might be a good idea. Let's do some different letters. Let's say that x plus y squared equals that side A. Okay, that might kind of help us out here. So the x is the 3, the y is the 6, and the a squared is what we're looking for. So that's 9, that's 36. Equals a squared, 36 plus 9, it's going to be 45. And then we want to square root that, and round that to the nearest tenth to find side A. So square root of 45 and 6.7. Okay, so 6.7. Okay, so that's one side. Now we need to find the other side. And that's the 6.7 right there. Okay, now notice how we have two sides now and an angle in the middle. So two sides, angle in the middle, that means law of cosines. All right, and we're looking for angle for side B. So we're going to set it up with b squared here And then a squared plus c squared equals 2 times a times c times cosine of that same opposite angle, which is b. Okay, so let's plug it all in. So a squared would be 6.7 squared plus the 6.9 squared minus 2 times those same sides. Hopefully I don't run out of room here. Times the cosine of angle B, which is 107. And remember, we take the square root of both sides there, and we're just looking for the side. So let's plug it all in. We got a square root there already, so we'll do 6.7 squared plus 6.9 squared minus 2 times 6.7 times 6.9. And make sure that you are separating all this stuff as you type it. Like, don't let, don't, like for instance, on that last part, if you click that, don't click like parentheses again, like this. Okay. That might mess things up depending on what you're doing. All right. So make sure I kind of click outside of the parentheses and start a new one. Okay. And technically that actually wouldn't have done anything in that case, but sometimes it might. Okay. And then times cosine of 107. So we get 10.9. Okay. And make sure rounding is good too, because, we could be, once we get the perimeter, it could be pretty close. So let's add all these up now. Okay, so if I add all these up, 6.7 plus 10.9 plus 6.9, it's going to give us P. So let's add it up now. And see if we are equal to 26 or less than 26. Hopefully we didn't go over. If we went over, that means she's not following the guidelines, which I don't know if that means anything. We're at 24.5 feet. So if she's at 24.5 feet, is that less than 26? Yes. So yes, she is under 26 feet. So because for perimeter, we added it up, it was 24.5, okay? So again, even if you're over by like 0.1, that's still over, right? It's not following the guidelines. Now, if an inspector came and you were 0.1 feet over, they might let that one go, right? If that even matters or not. Okay, that's it.